This is section 4.3, part 3, where we are going to continue factoring, and we're going to look at factoring special patterns. The first special pattern we're going to look at is called the difference of two squares. And there's a logical reason why it's called that. It's called the difference because you're going to have subtraction. And it's called two squares because each of the numbers that you're going to see, or each term I should say, is actually going to be a perfect square. You can take the square root of it and get a nice number. Alright, it's a perfect square. So, we've got the formula a squared minus b squared equals a, the quantity a plus b, times the quantity a minus b. As I said, we've got two perfect squares, so when I take the square root of a squared, what do you get? A. When you take the square root of b squared, what do you get? B. And then one quantity will be addition, one will be subtraction. So that's what you're looking for when you want to analyze, do I have a special pattern? If you see a binomial and you're asked to factor, you need to ask yourself three things. Number one, well, do I have a binomial? And you will, alright, if it's two terms. Secondly, is there a subtraction? So I've got binomial, two terms. Is there subtraction? Yes, there is. Okay, so now the third and final thing is key. Are each term, or is each term a perfect square? If you answer yes to that final question, you know you have a difference of two squares. So here we have x squared minus 64, binomial subtraction. Each term is a perfect square. And what I mean by that is if I take the square root of my first term, I get a nice solution. Square root of x squared is x. If I take the square root of 64, I get 8. So x squared is in the spot of a squared, so after I take the square root of a squared, I get a. Take the square root of x squared, I get x. So that must mean x is in the spot of my a. So when I start plugging into this formula, wherever I see an a, I'm going to plug in an x. 64 is in the spot of b squared, so when I take the square root of b squared, I get b. Take the square root of 64, I get 8, so that must mean 8 is in the spot of b. So when I go ahead and start plugging numbers into this formula here, 8 is going to go wherever I see a b. So my solution is going to be two quantities. One of them is going to be addition, one's going to be subtraction. Where I have a's, I plug in x's. Where I have b's, I plug in 8's. So my answer here is going to be x plus 8 times x minus 8. And again, you can check by foiling. So we'll FOIL and say x times x is x squared. X times negative 8 is negative 8x. 8 times x is positive 8x. 8 times negative 8 is negative 64. Combine like terms. Notice negative 8x plus 8x are actually going to cancel. And we're going to be left with x squared minus 64. And this is exactly the same as the problem we started with, so we know we got it right. Let's go ahead and try a second one. Okay, I see a binomial. Alright, two terms. Next, do I have subtraction? I do. I have subtraction. So the third and final question, is each term a perfect square? X squared, can I take the square root of that? Square root of x squared, well that gives me x, so we know that's a perfect square. What about the second term, 100? Can I take the square root of 100? Yes, I can. I get 10. So, I know I have a special pattern, the difference of two squares. So, I'm going to simply say I have x plus 10 and x minus 10. One will be plus, one will be minus. There's your answer. If you tried to FOIL again to check, you would see your middle two terms would cancel. So you'd see that when you go x times x is x squared. X times negative 10 gives me negative 10x. 10 times x is positive 10x. And 10 times negative 10 is negative 100. As I said, look at your middle two terms. Negative 10x plus 10x. They will cancel. And you're left with x squared minus 100, which is just exactly the way we started. Let's go down and look at another special pattern. and we have a perfect square trinomial. And there's actually two different types of perfect square trinomials. We're going to look at our first one, which we have the formula right here, where we have an a squared plus 2ab plus b squared. So if you're looking at a trinomial, you can factor it the way we factored previously in the first two parts to this section. But a nice shortcut is to notice that the first term is a perfect square and the second term is a perfect square. Alright? If you notice that, you can simply say, oh, x squared, if I take the square root of x squared, what do I get? I get x. If I take the square root of 49, is that a perfect square? It is. 7. Alright, so if you notice that, look what happens. You can set it up as a plus b squared. What's in the spot of a squared? X squared. So that must mean x is my a. What's in the spot of b squared? 49. Take the square root of that, so that must mean 7 is my b. So I can simply say, instead of a plus b squared, I'm going to have x plus 7 squared. And why do I have a, why do I have a plus? Well, you have a plus because you have, number 1, 2 perfect squares, and you have 2 addition signs. Alright, so I alluded to the fact that yes, you can do it the quote-unquote old-fashioned way, or the way we looked at in the first two sections, and I'll show you that real quick here. I'll do it in another color. Alright, so we'll do it over here in gray. So I've got x squared plus 14x plus 49. So yes, I can go through, and I'm not going to look at all the factors. Alright, 1 and 49 won't work, right? So go through all your factors. What numbers go into 49? Our answer would be 7 and 7. 7 times 7 is 49. 7 plus 7 is going to give us 14. So we've got two factors that multiply together to give us C, two factors added together to give us B. So then we would say, oh, our answer is going to be x plus 7 times x plus 7, which is the same thing as x plus 7 squared. And that's the exact same answer we have here. So you can really do it either way. All right. I personally do not care which way you do it. All right. If you have the shortcut, all right, where you notice you have a nice perfect square trinomial, you can go and do it the first way that we looked at, or you can go back if you feel comfortable doing it the way we did in the first two sections. Feel free to do that. But for our purposes, for the remainder of these problems, I'm just going to show you this way. All right, but know in the back of your head, you can always do it this way as well. So let's come down and look at one more. X squared plus 10x plus 25. Look at your terms. All right, are they both perfect squares? X squared. Take the square root of x squared. What do I get? X. 25. Take the square root of 25. What do I get? 5. If they're both perfect squares, you notice you have two plus signs, so we know it's going to be x plus 5 squared. And there's your answer. Let's come down. We have one last one to look at, which is also a perfect square trinomial, but instead of plus plus, you have minus plus. So you have a squared minus 2ab plus b squared. If you have a nice perfect square trinomial, it can be factored into a minus b squared. So again, you want to look at your terms. Say, oh, okay, I've got x squared. What's the square root of x squared? That's x. I also have 100. We looked at that before, and we all know that square root of 100 is 10. And I notice I have a minus here, a plus here, so it can be expanded into the form a minus b squared, or factored into the form a minus b squared. So I've got x minus 10, x and 10, x minus 10 squared. There's my answer. And again, if you are unsure, feel free to go ahead and FOIL. X minus 10 times x minus 10. X times x is x squared. X times negative 10 is negative 10x. Negative 10 times x is negative 10x. And negative 10 times negative 10 is positive 100. Combine your middle two terms. Negative 10 minus 10x, or negative 10x minus 10x, is negative 20x plus 100. And we have the exact same piece that we started with, our exact same trinomial. So, last one. X squared minus 18x plus 81. We've got a trinomial. I'm going to analyze the first and last term. Are they perfect squares? X squared, take the square root of it, I get x. 81 is a perfect square. When I take the square root of 81, I get 9. Since I have a minus and a plus, I know I can factor it into x minus 9 squared. And again, if you FOILed, you'd see you'd get x squared minus 18x plus 81 as your solution. Alright, so you'd know you'd end up with the same problem you started with, so you know you have the correct answer. So that is section 4.3.